Welcome back to Who Wants to Be a Mathematician? I'm Mr. Hill, and we're going to be talking about families of graphs. So we just did our basic parent graphs. Now we're going to go over types of transformations. So, a transformation is how you shift. These are just called shifts. So if I shift along the x direction, it's a horizontal shift. If I shift along the y direction, it's going to be my vertical shift. Two other types of shifts we're going to be talking about are going to be called dilations, and these are going to be making our graphs look steeper, and also making them look shallower. So steeper and shallower, and then the fourth one is going to be reflections. So we're going to be reflecting things. So starting off, we're going to talk about horizontal translations, horizontal shifts, x direction, so shifts here. So what I want you guys to do, parent graph, x squared, we know this from before. What I want you to do is, for your friendly graph here, I want you to put that in your calculator and just draw a little thing about what it does. And then for your next one, do the same thing, plot it in your calculator, do a little jot of what it does, and let me know. So pause me, do a little quick sketch, put it in calculator, find out. So you should be paused right now. If you're not, pause and go do it. Alright, and we're back. So, what does our y equals negative x minus 2 quantity squared? Well, it shifts it to the right. 1, 2, shifts it to the right 2. So here we go. Whoop. Whoop. That's our new one. And how about the other one? It shifts it to the left 2. Whoop, whoop. So, if our C is positive, which direction does it move it? Moves it to the left. Now, if our C is negative, which direction did it move it? It moved it to the right. So we have right and we have left. So this is kind of opposite thinking, right? If you want a positive number, you kind of think it should go in the positive direction. Negatory. So if you have an x shift, it's going to be opposite of what your intuition says. So if you have a plus number, it moves it to the left. If you have a negative number, it moves it to the right. All right, here we go. Just going to move that out of the way, pretend it's not here. Just don't tell anyone, okay? Alright, let's talk about some vertical shifting. Not bad. It's going to be pretty good, pretty solid. Same thing, we have our parent graph. What's our parent graph going to do? Kind of has a weird dot at 0, 0. Then we're just going to avoid that dot. Just avoid that dot. And now I want you guys to pull out your calculators, pause me, and plug in this equation. Give a little sketch. Plug in this equation. Do another little sketch there. And see what you come up with. So I'm paused right now. Plug in the calculator. Do a little quick sketch. Alright, so I'm back. So if I have a negative, it looked like it moved down a little bit. That dot moved down. So my graph does this. I avoid that dot. And if I have a plus 2, it looks like I moved up. That's good. I'm moving up in the world. So, if we have a positive number, that means we're moving in what direction? We're moving up. And if I have a negative, what does that mean I'm doing? I'm moving down. So that's good. So, as a little tiny review, I'll just move that off the way like it doesn't matter. So if I have a function and my x is being acted upon by a number, some number, whatever it is, then that means that I'm going to be doing a horizontal shift. Horizontal shift. If I have a function and my quantity, whatever my x is doing on the inside, whatever that quantity is, and I have some number that's being added or subtracted to the outside, this is going to be my vertical shift. Oh, that's an E, isn't it? Vertical shift. So whenever you see something on the inside, horizontal. Whenever you see something on the outside, vertical. Done. Nice and easy. Alright, next page we're going to move on to dilations, reflections, after we do a quick little example. So I'll see you then.